Hi, so today I'm going to talk about teaching for application, how we can teach students to apply or transfer their knowledge. And it doesn't matter whether you're teaching about natural selection in biology, or teaching about impressionism in art, or teaching about probability in maths. Essentially what we want people to do is be able to apply that knowledge, the underlying principles, to different contexts. And that's notoriously difficult. They've done lots of experiments with math students, with medical students, with economics graduates, with physics graduates, and it's always the same. They find it very difficult to transfer their knowledge to new contexts, both within the things they're learning and in wider life. And the reason for this is that the principles come down to the context in which they're introduced. So, Tim talked earlier about context-specific learning. It implies the context in which you learn it, but also the context of the examples that you're learning from. So if you teach natural selection with a specific example like the peppered moth is the thing that the students remember about. And a few years ago when I was training to be a teacher, Tim came and talked to us about his experience in education, and he told us about how when he was at school he used to steal crisps from students. And I remember that vividly, and ever since I've stolen a huge amount of crisps from students. And I started thinking recently, well, maybe there was an underlying principle that I was missing here. And I think I got it. So recently I've been seeing sweets and biscuits and all sorts of things. And some scientists called Lowenstein and Gentner were interested in this, not in the crisp stealing or biscuit stealing, but more in how you teach students to apply their knowledge to different contexts. And what they did was quite a simple experiment. They took economics students and they initially taught the students the principle they wanted to understand. They showed them two examples of it and then they asked them to apply it. And they found they had about a 20% success rate at applying that knowledge, even though the opportunity to apply was immediately after they taught them and given them the examples. They then repeated the experiment with some different students. This time they taught them the examples, they taught them the principles, they gave them the two examples, they asked the students to draw out the principle, like show them how the examples illustrated the principles, and then they asked them to apply it. They had about 40% success rate at applying and understanding. In their third experiment, they just gave them the two examples, and they said to them, we want you to compare and contrast the examples. So essentially what the students were doing was drawing out the principles themselves. And this time when they got them to apply their understanding, they had a 60% success rate in transferring their understanding, because they took away the context-specific understanding. The understanding became about the underlying principles. So this really applies to what we do in science. Science education is really about knowing things and then applying them to new contexts. So it doesn't matter whether you're teaching about natural selection, osmosis, cell structure, it's about learning things and applying them to new contexts. So in Wheatley Park, we've looked at this and we've developed a set of success criteria for our lessons when we're teaching people to apply things to new contexts. And I've handed out an example of what one of our activities might look like, but in the case of the example I've given you, it's how I would teach other managers or teachers to teach the skills of application. So in the example I've given you, I've given 3 different examples of teaching the skills of application. I would then ask you to draw out the underlying principles by comparing and contrasting using the Venn diagram. On the periphery of the Venn diagram, you would have the context-specific stuff. In the centre of the Venn diagram, the key ideas, the underlying principles. I would then get the students to try to apply that knowledge to a new context and give them some feedback, or get some feedback myself by doing some diagnostic questioning. And then I get them, based on that feedback, to have another go at applying it to a new context. And something that we're now starting to work on is whether the students can, the learners can identify additional contexts in which the principles apply. So contexts that are already in their memory, can they apply these new principles to already existing concepts? And there's some other research that I've read recently that shows that if you teach in this way, most students can do that. So I'm just going to leave you with 2 questions that we're now thinking about in terms of how we deliver this. One is about the language that we use. Should the language be challenging? It's about the sort of idea of desirable difficulties. If we make the language too easy, if we just make the language the same every time, will the students draw out the principles too easy and not really understand them? And the other thing we're thinking about, how useful is it to show examples of where the principles don't apply? So today, period 5, I was teaching students about osmosis, and I taught them in this way. And we were talking about strawberry cells and how water moves in and out of strawberry cells. And I really felt at the end of my lesson the students had learned to apply their knowledge of strawberries. Because Dan Scoville turned to me and he said, "Sir, your head is shaped like a strawberry."
Let's have hot water, please, from rainfall.